Okay, let's go further from where we left the previous video. So in the previous video, I explained what the problem was, that we had to solve in this problem. And what we did is separate the inverse kinematic between the card and the end effector because we wanted to control them separately. And we built the code in VREP that if we press the grip button of the right controller, that we could control and move the end effector of the robot. And if we press the left grip button, then we could move the card on which the robot is placed. And we wanted to do them separately because if we would automatically let the complete thing solved by the inverse kinematics, then the card would move too erratically to give realistic motions. So in this video, what are we gonna do now? The main thing, I will see how far we get, but we will um, make program the snapping of the end effector. Why is this necessary? We can manually align the target position with the end effector position, but actually what we want to, because the problem is that this is not precise, so we want the exact position, and so that's why we also want to automatically solve the inverse kinematics problem to that position to get the extra precision. So let's program this now. Um, let's open our script again. Um, let's first discuss a strategy to do this. Right now, the inverse kinematically is continuously solving to the targets, and we could move the end effector by making the targets a child of the controller. So if the controller moves, then their children will move with them. And we're going to use the same mechanic. So I have here a dummy that's the target, and we're going to move this in our application MATLAB to the desired positions. And snapping would mean that um, the target, this target of the end effector, would match the position of this target. So that's basically it. And the control we want, for which we want that to happen, is the right trigger. You can change this if you want, but I choose this one. So if the1, this is a Boolean, explained this in previous video, the interface talks to MATLAB by setting string signals. So if this string signal is 1, means that PREP, the user in VR pressed this button. So if we check if it's 1, then this is a Boolean that's true if that button is pressed. So if this button is pressed, then we execute this code. Uh, yeah, no. This one is to accept a new position. We want to snap it if um, we press the grip button of the left controller. So it's this then. And so what we do, we need one more handle, like the actual target. So so okay. Now that's the handle we need. So let's program what needs to be done. it's set object position. We want to set the position of target 1, which is the end effector target, this one, in the reference frame of the actual target to 0, 0, 0. So that's easy. Same with the orientation. So in this reference frame, it will be 0, 0, 0, and that's basically it. Okay. And another thing that we saw in the video, a more complicated thing is if I press the button. Let's first test this. So let's show you again what happens. I think I closed it, so okay, but I need to do this. You don't know what it is yet, but okay. So we want the end effector to go to this position, and this is the left controller. So if we press the white button now, you see that it already snaps to the final position. After this, we can still move it, and if we press the white button of the left controller, you see it snaps. So this works. So that works. Second thing, you saw that if we in the video, if you go back, is that if we press that button longer, we also solve for the orientation, because what you saw now, that only the position was matched. So how are we gonna do this? So if you see in the inverse kinematics of the inverse kinematic element 1, this is the one of the robot, and you see now, you see this key element, you see that it doesn't solve for the gamma angle, so it uh, only solves for alpha, beta, x, y, z. And by changing these flags, we can change the behavior, inverse kinematic elements. So this is actually more challenging, but to do this in VR, but you can do it. So let's program that we can change this dynamically. So how can you do this? You have these constants x constraint that you can concatenate using the symbol function. So now we want to accumulate a bunch of this. So let's first make it x, y, z separately. So yeah, so I will, okay. This is not necessary anymore. So, okay, what we want is Y, Z, X. And we also want the alpha beta, like you saw later, uh, previously. So let's also add this one. You can find these constants in the documentation. I won't retype it, otherwise it would take too long. So these are the flags that are checked right now. We also want to optionally solve for the gamma. So now we have X, Y, Z, and alpha, beta, and these are encoded in the flags right now. So let's do this right now. Let's make a count variable because we want to solve for the gamma only if the user presses the button long enough. So let's make a count variable to count how long this is pressed, the button. So let's initialize it at 1. And if count is smaller than like 20, for example, let's also already put an else there. Then, yeah, right now we miss a few things to this. So let's get a few more handles. ICA inverse kinematics handle 1 is sim get EK group handle get E yes. And the first one of the robot manipulator is called just K, and the second one, I don't think we need it. No, okay. Again, we only need to solve the manipulator. So what you can do here then is you can find this function and what it does uh, in the online documentation. But what you need is the inverse kinematic group handle, which we have. We also need the tip object, so tip dummy handle. We don't have that one, we only have the targets. So let's also get the tip. And how is the tip called? It's not a nice name, but so where do I get this from? It's this tip. So you see the name matches. Uh, so okay, tip, and then the constraint. The constraint is the flags that we have prepared here. So if it's below 20, then we just want it to be solved regularly. So that's these flags. And what do we want if it's yeah, the other things need to be, we don't care about those, so let's make them nil. And what do we want if it's pressed more than 30, 20 counts? I don't know what it is. We'll see later if this time is okay. Okay, element properties, okay. And then we want to solve for something more. So we can use the Boolean OR again. And we want our old flags and to concatenate them with the gamma constraint. So this is one extra constraint, and we're still not interested in all the other things. So let's make them nil. Yeah, let's fix the count variable. Um, and if the button, the left trigger is not pushed, then we want the count to be 0 again. Okay, that fixes this, I think. Let's test this. So let's start the simulation in the window, start the interface. Let's rerun this one. And now it's not important what this one does. Okay. So the left button is the one with right now the C, the blue, is aligned. But if we press it for longer, then there is some issue. Okay, this scene is probably way too complicated for a tutorial. So much that can go wrong. But we're living on the edge, so why not try to do this? Okay, so there was a bit of a bug in the code, so I found it right now. So if you can see, uh, if we move it, then we press it shortly, then the orientation is not aligned. But if we prove it, we push it longer, then the orientation is solved. You see there's two phases, which gives the user more control. I will show you what was wrong. So what I did here is I forgot basically the tip, to include the tip in the function, and this gave an error. That's the risk I take by doing this kind of complex demo. Okay, so this works right now. This is, I think, good time to cut the video. And in the last part, we do some aesthetic things to make it look better and clearer for the user.